Welcome to EDU World Space.
Suppose that this series that's given is convergent, and then we'll try to prove that this sum over here by flipping an with 1 over an is divergent. So here, let's go ahead and prove this. So let's start off by just letting everyone know we're doing a proof. So let's write proof. And then we have, since this series converges by the divergence test, we must have that the limit of as n goes to infinity of an equals 0. The divergence test says that every time a series converges, the limit of an must equal 0. However, if we look at our new series over here, let's not call this an because an is already being used. So let's call this an prime equals 1 over an. So an prime is the nth term that's being added in the series. If this limit goes to 0, then the limit as n goes to infinity of an prime, well, this is just going to equal, well, we have 1 in the top, but what is that denominator going to? That denominator is going to 0. So here, this limit will not exist. So this limit is either, it may exist. It's either infinity, negative infinity, or undefined. And it really depends on the ANs. The ANs are getting close to 0 if they're only positive. So maybe a graph here. So if the ANs are only positive, then 1 over AN will be positive and very big. That would go to infinity. If ANs were negative, for the similar reasoning, the limit would go to minus infinity. However, AN could be both positive and negative, alternating. In that case, 1 over 0 in the limit will bounce around between negative infinity and infinity. In that case, the limit will be undefined. However, these are our only 3 cases since we have a 1 over 0 in the limit. A limit of this form is not going to be a real number. So we have that the limit of an prime is not equal to 0. So that means that this new series, an prime, or let's go back and actually call it what it is, 1 over an, is divergent. And it's divergent by, the book calls the divergent by the test for divergence. We computed the limit of an, or an prime, for our new series. In the limit, this term does not go to 0. Therefore, the series is divergent by the test for divergence, and that's our final answer.